A into E. Next one is bulk modulus. B is equals to, what is the formula we got? Which stress by which strain? Volumetric stress by volumetric strain, that is pressure divided by minus delta V by V. Why here pressure we got? Because we will observe the bulk modulus in case of fluids. In case of fluids, whenever you are applying the force, then pressure will be developed there. That is about the bulk modulus. In bulk modulus only we got one more formula. What is that? Compressibility. Compressibility is equals to, what is that? 1 by bulk modulus, reciprocal of bulk modulus. Next one is shear modulus or rigidity modulus. Neta is equals to, what is the formula we got? Tangential stress by tangential strain. So tangential stress is what here? F by A, and then strain is how much? Theta. So that why shear strain formula, what is the formula of shear strain? Tan phi is equals to, what is the formula? X by L. I have to write phi here. So that neta is equals to F by A divided by phi. That is about the 3 modulus of elasticities. In that modulus of elasticity E is increasing nothing but what is increasing there? No, whenever the material whichever is having more E value, that is more elastic or less elastic? More elastic. As the E value increases, then elasticity also increases. In that we have discussed about the different factors whichever will affect the elasticity of a material. So in that, first of all, temperature rises, then what happens? Elasticity will decreases. Elasticity will decreases. Why? Because the strain increases. Length increasing nothing but strain is increasing. The E is inversely proportional to the strain we will get. If the strain increases, then what happens? Elasticity will decreases. If elasticity E is decreasing means automatically elasticity also decreasing only. That is about the temperature effect. And after that we have discussed about the impurities. Impurities, what we have discussed about the impurities, how it will affect? Depends on the impurities. Depends on the impurities. If the impurities whichever we are added are elastic nothing but the elasticity will increases. Inelastic we have added nothing but the elasticity will decreases. And also after that we have discussed about the density. Density increases, then what happens? Elasticity increases. Why? Because yesterday I said you one shortcut method that y is equals to mgl by ae. In the place of m, what I can write? Rho into v. So that rho is directly proportional to y, so that it will increases. Otherwise you can take it as whenever the density is increasing, at that time I cannot elongate more, elongation will be less. So whenever the elongation is less means strain is less. As the strain is less, then what happens? Nothing but elasticity will increases. That is what that strain is less nothing but what is that? Strain will be inversely proportional to the elasticity, right? So the strain is decreasing nothing but elasticity will increases. That is about the different factors whichever will affect the whatever that elasticity of a material. That is what we have discussed. After that, Poisson's ratio we have seen. What is the Poisson's ratio? Nothing but sigma is equals to lateral stress by longitudinal strain. Lateral strain by longitudinal strain. So that lateral strain nothing but what? Delta d by d, that divided by longitudinal strain nothing but delta L by L. And also whenever the length is increasing, at that time what happens? The diameter will decreases. So that what we get here? Minus delta d by d divided by delta L by L. Lateral strain by longitudinal strain. So that here one formula I have written finally, conclusion formula, delta d by delta L into what I can write? L divided by d. That is the formula of the sigma. Correct or anything wrong? Correct only, right? So that is delta d by d divided by delta L by L. That is about the Poisson's ratio. And also we have seen the Poisson's ratio limits. So theoretical limits are from where to where? Minus 1 to 0.5, and then another practical limits are 0 to 0.5. Nothing but the positive value will be, in case of theoretical or practical, positive value will be 0.5 only. In case of theoretical, the negative value is minus 1, and then in case of practical, that is 0. These are the limits of sigma we got, limits of the Poisson's ratio. And after that we have seen the this one behavior of a wire under gradually increasing the load, that is stress strain curve. In that, up to O to A, what happening? Up to O to A, Stress is directly proportional to strain, so only we call it as what? Proportionality limit, obeys Hooke's law. A to B, what happening? Elasticity is there, but stress is not directly proportional to strain, so only we call it as elastic limit. B to C, what happens? Yield point, it will lose as the elastic nature, so only that we call as yielding point. Then C to D, what happening? For the smaller stress also there is a longer strain we got, that is a permanent set, otherwise ultimate tensile strength we have discussed. And after that D to E, what happening? Decreasing the stress also there is a increase in the strain. After E, what happens? The wire will get breaked, so only that point we call as breaking point or fracture point. And also in that I said, based on that graph, I said two types of materials. One is ductile material, another is brittle material. Ductile material, the region of A to D is smaller or larger? Ductile nothing but it is not breaking nothing but it is elongating easily, so that will be larger. In case of brittle material, A to D region is very smaller, so only the wire will get breaked easily. That is about the graph we have discussed. And also whenever you see, I have given two materials yesterday, A and B, so that in whichever theta is more, for that what happening? Elasticity is more or less? More elasticity. Why? Because stress by strain, tan theta is equals to stress by strain. If the stress by strain is more, means automatically elasticity also more only, and then we have compared two materials like that. And also we have taken two horizontal rods A and B, and also we have discussed about the elasticity of the two rods. In that whichever is what elongating less, that will have more elasticity. So whatever you think, whichever is elongating easily, that is having more elasticity, like that you will think, but that's wrong. Whichever is having less elongation nothing but what? Less strain nothing but more elasticity. So all the materials whichever are not elongating very large values, so that will have the more elongation. Stiffer objects will have more elasticity. Clear? Stiffer objects will have more elasticity. So only I said that steel is elastic than rubber. What is the reason? In rubber strain will be more, so that elasticity will be less. In steel strain will be less. Why? Because elongation is less only, so that elasticity will be more in that case. We have discussed that and all yesterday, and also we have done some problems based on the bulk modulus and then Young's modulus. Bulk modulus problems we have done or not? Done? One problem we have done. Next, write a problem. You are not feeling well now, Uday? Don't sit at the fan. ಬರ್ತಾ ಇಲ್ಲ? Bulk modulus ಯಾವುದು problem? 0.10% da? That one only we have done. I have given one problem for work, I think. Compressibility problem, no? Yes. Chi. First time adi. Are Yuvaraja. Find the decrease in volume of sample of water from the following data. Initial volume 2000 centimeter cube. ಆಯಿತಾ? ಅದೇ ಎರಡು ಪ್ರಾಬ್ಲಮ್ಸ್ ಕೊಟ್ಟಿದ್ದೀನಾ? ಕಂಪ್ರೆಸಿಬಿಲಿಟಿ 25 × 10⁻11 ಕೊಟ್ಟಿದ್ದೀನಲ್ಲ, ಫಿನಿಶ್ಡ್ ಆಯಿತಾ? 0.45. ದಿಸ್ ಒನ್ ಐ ಸೆಡ್ ಟು ರಿಮೆಂಬರ್ ದಯ್ಯಮ್. I said to remember, right? Yesterday you got that wrong answer actually. What's the answer you got? You have to get 0.45 centimeter cube. That is the correct answer. Yesterday so many people said that 10 something. 5 you said. That is 0.45 centimeter cube. What is the formula? Delta V is equals to, what is the formula? You have to find out delta V, right? Delta P by delta V by V, that's it. This is compressibility, right? So that 1 by C is equals to delta P by delta V by V. What you have to find out? Delta V only. So that the answer is 0.45 centimeter cube. That's the correct answer. ನಿನ್ನೆದ ನೋಟ್ಸ್ ಕೊಡು ಒಂದ್ಸಲ, ಇನ್ನೊಂದು ಪ್ರಾಬ್ಲಮ್ ಹೇಳಬೇಕಿತ್ತು. ಬಲ್ಕ್ ಮಾಡ್ಲಸ್ ಎರಡೇ ಪ್ರಾಬ್ಲಮ್ಸಾ? ತ್ರೀ ಪ್ರಾಬ್ಲಮ್ಸ್ ಆಯಿತಾ? ಸರಿ ತರಿ. ನೆಕ್ಸ್ಟ್ ಒನ್, a 4 centimeter cube upper face, a 4 centimeter cube a 4 centimeter cube a 4 centimeter cube has upper face displaced by 0.1 mm by a tangential force of 8 kilonewtons then calculate the shear modulus of the cube. Easy, direct substitution, only do that. I am asking the shear modulus there. Do that shear modulus, you have to find out. What is the shear modulus formula? F by A divided by X by L. How much? 2000. 2 into 10 power 5 ಬರಬೇಕು. 2000 ಬರ್ತಾ ಇದೆ. 2 into 10 power 10 square. What's the answer you are getting? 2 into 10 power 4, 6, 5. See that I am asking to find out the rigidity modulus there. So neta is equals to, what is the formula? Neta is equals to F by A divided by X by L. So force is how much force applied? 8 kilonewtons. 8 kilonewtons. That divided by area is how much? L is how much? Length is 4 centimeter. Nothing but what will get here? 16 into 10 power minus 4 you will get. Why? Because 4 centimeter you have to take in meters. So that is area, nothing but what will write? Area is equals to L square we will take. That divided by displacement of the upper face is how much? 0.1 millimeter. 0.1 into 10 power minus 3 divided by length is how much? He said 4 centimeters. 4 into 10 power minus 2. That's it. So here how much you will get? This one is 10 power minus 2 and then 10 power minus 1 here. Otherwise directly I can write it as FL by X into A. Do not confuse. 8 into 10 power 3. Length is 4 into 10 power minus 2. X is 0.1 into 10 power minus 3 and then area is 16 into 10 power minus 4. It will be easy to calculate here. So here this one 4 4s and then this will be 2 times. So that 2 is remaining. This together I can write as what? 10 power minus 4, 10 power minus 8 and then 10 power minus 2. How much is remaining down? 10 power minus 6 is remaining. 10 power minus 6 is going up, nothing but how much it will become as 10 power 9. So this is a Newton per meter square. That is the modulus of rigidity. Look at the problem. Look at the problem once. Rigidity of modulus is equals to neta is equals to what is the formula? Force by A divided by angle of shear you have to take here. Tan phi is equals to x by L. This is shear strain we will take. So that for the easy calculation purpose I am writing it as FL by A into x. Then force is how much here? 8 kilonewtons they are saying. So that only 8 into 10 power 3. And then length is how much? 4 centimeters. So that only 4 into 10 power minus 2. They have not given the area. For that area what you have to do? L square only, right? So L square nothing but 4 into 4 is 16 into 10 power minus 2 whole square nothing but 10 power minus 4. And x is displacement is how much? 0.1 millimeter. 0.1 into 10 power minus 3. Whenever you calculate everything, then neta is equals to how much you are getting? 2 into 10 power 9 Newton per meter square. Why you got different values? 2 into 10 power 5, 10 power 6 like that? What you have not taken? Millimeters, huh? Next one. Consider an Indian rubber cube. ಸ್ವದೇಶಿ ವಸ್ತು ಯೂಸ್ ಮಾಡಬೇಕು. ಕನ್ಸಿಡರ್ ಆನ್ ಇಂಡಿಯನ್ ರಬ್ಬರ್ ಕ್ಯೂಬ್ ಹ್ಯಾವಿಂಗ್ ಮಾಡ್ಯುಲಸ್ ಆಫ್ ರಿಜಿಡಿಟಿ of 2 into 10 power 7 dyne per centimeter square. 2 into 10 power 7 dyne per centimeter square. And of side 8 centimeters, and of side 8 centimeters. Full stop. If one side of rubber is fixed, while the tangential force equals to is equals to weight of 300 kg is applied to the opposite face, then find out the shearing strain produced, and the distance through which the strained side moves. And answer. First of all, read the question, understand what they are asking there. Calculate the problem, get the answer. What's the answer you got? Strain produced is how much? Strain you have to find out, and then displacement you have to find out. What is the answer angle you got? Shear angle. See, that's not much tough problem. Little twisted, that's it. So look at the board. They said that one Indian rubber cube of how much they said modulus of rigidity is how much 2 into 10 power 7 dyne per centimeter square, and of side how much L is equals to 8 centimeters. If one side of the rubber is fixed, while the tangential force equals to the weight of 300 kg. Nothing but what is the force they have given? 300 kg weight, nothing but how much? 3000 newtons. That is the force you have to take. Weight of 300 kg. Weight of 300 kg, nothing but mg. Weight of mass. Mass weight is how much mg? 300 into g. Weight of 300 kg units ನೋಡಲ್ಲಿ 300 kg ಕೊಟ್ಟಿದ್ರಲ್ಲ 300 kg ಮಾಸ್ಗೆ ವೆಯ್ಟ್ ಎಷ್ಟಾಗುತ್ತೆ ಅಷ್ಟು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ರು ಅನ್ನೋ ಅರ್ಥ ಆಯ್ತಾ. ಸೊ 3000 is the applied force, and then what you have to find out here? Shearing strain you have to find out. For that, see that 300 kg weight, 300 kg weight nothing but what you have to take? 3000 newtons. That is the force applied. That is in that mainly in that line only the entire question is there. The weight of 300 kg nothing but a block is taken as 300 kg. What is the weight of that block? 3000 newtons. That is applied in the opposite phase they are saying tangentially. So that here force is equal to 3000 newtons. You have to find out the shear strain. What is the shear strain? Nothing but theta x by L. So phi is equal to x by L we have to find out. Did we know the x value? Don't know. Directly phi only we will find out. So what I can write here, rigidity modulus is equals to F by A divided by phi. This is only now our formula, F by A divided by phi. So you have to find out the phi value, nothing but phi is equals to F by A into neta. Correct? F by A into neta you have to get. So that phi is equals to F is how much here? 3000 newtons. That divided by area is how much? L is 8 centimeters. And also here everything given in dynes and then centimeters, right? You take this one also in dynes only. 3000 also in dynes only. Instead of converting 2 or 3, we can convert this one only directly. So that 3000 newtons nothing but 3000 into 1 newton is equal to how many dynes? 10 power 5 dynes. So that here what I can write here? 3 into 10 power how much? 8. 3 into 10 power 8 dynes. Look at the problem. I said that no need to convert these two. Instead of converting these two, you convert this one only. 3000 into newtons, nothing but 1 newton is equal to how much? 10 power 5 dynes. So that 3 into 10 power 8 dynes will be the force, applied force. So that 3 into 10 power 8 divided by area is how much here? L square. L square nothing but how much I can get? 64. There is no need to write again 10 power minus 4. Why? Because everything I have taken in CGS only. Clear? And then 64 into what is the area, and then neta. Neta is equal to how much? 2 into 10 power 7. So what will get cancelled here? This 10 will be there. Anything else? Nothing, right? 3 by 64 into 2 nothing but 128. 30 by 128 you will get. 30 by 128 nothing but I can cancel with 2, then 15 by how much it will be? How much? 64. 15 by 64 you will get. This is what you will get. Approximately what I can write, nothing but 1 by 4. Approximately. Nothing but our angle is how much? Nothing but 0.25. Approximately 0.25 radians. Angle no, so only you have to take in radians. Clear? Then I got the shear strain here. You have to find out the displacement. What is the shear strain formula for us? Phi is equals to x by L. This x only you have to find out. Then x is equals to what I can write, nothing but phi into L. So that phi is how much? 0.25 here approximately. Length is how much? 8 centimeters. Then what is the answer you will get here? 2 is the answer. 2 centimeter is the answer. Clear? Listen again. Listen. They have taken an Indian rubber cube. On that what they are doing, nothing but let me take this is the Indian rubber cube. Otherwise normal sponge you can assume. So lower end is fixed. And also this cube of rigidity modulus is how much? 2 into 10 power 7 dyne per centimeter square, and the side of one side of the cube is how much? They said 8 centimeters. Then you have to apply a force. That force is equals to how much? Nothing but 300 kg weight. 300 kg block is having how much weight? 3000 newtons. That will be equals to the applied force. Tangential force they are applying. That force is equals to the weight of a 300 kg mass. Weight of a 300 kg mass is how much? 3000 newtons only, obviously. 300 into 10 only will take mg. Weight nothing but what will take? Mg. Mass is how much? They said 300 kg. So that g is 10. So what is the force you will get? 3000 newtons. Weight of a 300 kg mass. That is the main twisting line in this question. So that weight of a 300 kg means 3000 newtons. Everything is there in CGS, so I will convert this one also in CGS only. Now they are asking the question is, you have to find out first of all shear strain. Shear strain means directly if you take x by L, you will not get the answer. Why? Because you don't know the x value also. They are asking x value also finally. And also you have to find out the displacement of the upper surface. For that, shear strain formula, shear strain you have to find out means, rigidity modulus formula is what? Force by area divided by shear strain. Shear stress by shear strain only. So that force by area we know every value, and then you have to get to know this one, then phi is equals to F by A into N. Force I have converted into the dynes. Why? Because everything is there in CGS only here. Otherwise, you are not comfortable with that, you can even convert this one also into newtons, this one also into meters. There is no problem in that. So whenever I convert like that, it will get cancelled easily. So that 3000 newton nothing but 1 newton is equals to how much? 10 power 5 dynes. 1 joule is equals to how many ergs? 10 power 7 ergs. Okay, that you have to remember. Now 3 into 10 power 8, that divided by area is how much? 8 centimeters. 64 centimeter square is the area you will get. That into neta is 2 into 10 power 7. Whenever you cancel everything, approximately the answer will be 0.25. Very small angle here. So only instead of tan phi, I have taken only phi here. And also now they are asking the displacement of the upper surface. For the displacement of upper surface, you have to take the again shear strain formula, that is phi is equals to the displacement of the upper surface divided by length of the cube. So the displacement is how much here? X, that is what you have to find out. Then phi into L. Phi is how much? You got 0.25 radians, and then 8 is the side they have already given. So what is the answer? You will get 2 centimeters is the displacement. Clear, right? Let's copy that. Write a problem which you can work out. A square lead slab, a square lead slab, a square lead slab of 50 centimeters, a square lead slab of 50 centimeters and a thickness 10 centimeters and a thickness 10 centimeters is subjected to a shearing force on its narrow face of magnitude 9 into 10 power 4 newtons. 9 into 10 power 4 newtons. Full stop. The lower edge is fixed to the floor. The lower edge is fixed to the floor. How much is the upper edge displaced? How much is the upper edge displaced if the shear modulus of lead is 5.6 into 10 power 9 Pascal. 5.6 into 10 power 9 Pascal. See that anywhere they have given Pascal nothing but indirectly what they have given Newton per meter square only. That is a measure of force. Pascal nothing but Newton per meter square only. One more they will give. One more unit of the force. What is the pressure? Nothing but atmosphere. 1 atmosphere is equals to how much? Nothing but how many Pascal? Nothing but 1.013 into 10 power 5 Pascal or Newton per meter square. Otherwise directly you can take it as 10 power 5 only. Most of the problem, almost 99% of the problems will take it as 10 power 5 only. Okay. So that 1 atmosphere they will give in terms of atmospheres also. So 1 atmosphere is equals to 1.013 into 10 power 5 Pascal or Newton per meter square. Anything is same. That is a unit of the pressure. Atmosphere also unit of the pressure. So that problem you can solve. Next one. Poisson's ratio we discussed no yesterday. Yes, few relations are there between the Young's modulus and bulk modulus and Poisson's ratio and rigidity modulus. I will tell you two formulas. You have to remember that there is no need of that derivation. Derivation will be very big derivations will be there. So you can remember those two formulas and then you can make the other two formulas. Okay. So that first of all, whenever you see the Young's modulus and then bulk modulus relations, and also we will see the bulk modulus and this one rigidity modulus and then Young's modulus relation. After that we club them and then we will get the Poisson's ratio there. Clear? Write that. Relation between important formulas. Relation between Young's modulus, relation between Young's modulus, bulk modulus, rigidity modulus and Poisson's ratio. Rigidity modulus and Poisson's ratio. So first of all, about the bulk modulus, Young's modulus and then Poisson's ratio. We will see the relation between them. B is equals to y by 3 into 1 minus 2 sigma. This is the bulk modulus relation. Whenever you see rigidity modulus, Young's modulus and then sigma relation is neta is equals to y by 2 into 1 plus sigma. These are the two relations you have to remember. So here the relation between B, y and sigma is y by 3 into 1 minus 2 sigma. Here this will be how much? Y by 2 into 1 plus sigma. This is about the rigidity modulus and then this is about the bulk modulus. Then you want to get only sigma value. You want to remove this y value. So that what we can do here? Equate both, that's it, divide both. Divide equation and then 1 and 2. Whenever you divide them, what will you get here? Y will get cancelled, right? Y will get cancelled and then what will be remaining for us? B into 3 into 1 minus 2 sigma is equals to what will be remaining? Neta into 2 into 1 plus sigma will be remaining. I am saying that here we got these two relations, means from that you have to get the sigma relation. For that what I am doing? Here I am just dividing equation 1 and then 2. Then what will get cancelled here? Y gets cancelled. Then this will go up and then this will come down. So what is our final relation will be? Beta by neta is equals to 2 into 1 plus sigma by 3 into 1 minus 2 sigma. This is what will be there. Now you have to do what? Cross multiplication to get the sigma value. I want to get only sigma. So I will do the cross multiplication here. Then 3b minus 6 sigma b, that is equals to 2 neta plus 2 neta sigma. Correct? Cross multiplication is correct. Then what you have to get? Only sigma value you have to get. So send 6 sigma b that side and then get everything this side. Then what will be there here? 2 neta sigma plus 6 sigma b is equals to what is remaining here? 3b minus 2 neta. Check that I am writing directly everything. Huh? He is calling, listen. So that here 2 neta sigma plus 6 sigma beta is there. From this what I can take common? Sigma I can take common. Why? Because I want to find out that value only. So that sigma is equals to what is remaining here? 2 neta plus 6b, that is equals to 3b minus 2 neta. Then sigma is equals to what I can write means 3b minus 2 neta, that is equals to 2 neta plus 6b. That is what the sigma relation. And moreover these are not much important, but we cannot take the chance. First two you have to remember, automatically you can solve the third one. Copy that. So first of all, the relation between B bulk modulus, Young's modulus and then Poisson's ratio is B is equals to y by 3 into 1 minus 2 sigma, and then for the neta what will get, instead of y by 3 y by 2 into 1 what will get 1 plus sigma. Now you have to get the Poisson's ratio formula. For that I am just dividing both. Whenever you divide both, what will get cancelled there, y will get cancelled. After that this will go up and then this will come down, so that whenever you cross multiply them and then you have to take the sigma as common and then get the sigma value. Sigma is equals to what will get 3b minus 2 neta by 2 neta plus 6b. This is what you will get. Nothing but whenever you see this one also, they easy to remember, 3b minus 2 neta divided by 2 neta is coming as it is. For this again you will get 2 times here, that is 6b. That is about the sigma formula. And also whenever you come to the relation between the Young's modulus and then bulk modulus and then sigma, relation between the Young's modulus, bulk modulus and then rigidity modulus, at that time your formula will be 9 by y is equal, this one is important, 9 by y is equals to 1 by neta plus 3 by b. 9 by y is equals to 1 by neta plus 3 by b. Without sigma, only Young's modulus, bulk modulus and then rigidity modulus. Again from this only you can get, from this only, this time what you have to cancel, sigma you have to cancel. Once you cancel the sigma, at that time you will get this answer only, 9 by y is equals to 1 by neta plus 3 by b. That is the relations between the Poisson's ratio, Young's modulus, rigidity modulus and then bulk modulus. Clear? Then write a problem. This portion is little bit memory based. A material having Poisson's ratio, 0.2, Poisson's ratio 0.2, a load is applied on it, due to which it suffers the longitudinal strain, 3 into 10 power minus 3, 3 into 10 power minus 3, then find the percentage change in its volume. Find the percentage change in its volume. Little twisting question only. See that material Poisson's ratio they have given, sigma they have given, and also longitudinal strain given, asking the percentage change in volume. How to do that? What you have to find first of all? Delta V by V you have to do. And wire they have given here. Wire you have to take it as cylindrical wire. Take it as a cylindrical wire and then get the answer. Little twisting, last line is twisting little bit. Uday, open that windows now. Suffocation ಆಗ್ತಾ ಇಲ್ಲ ನಿಮಗೆ? You sit under the fan, what will be? ಅದು ಕೂಡ first of all take the Poisson's ratio formula. How much ma? What is that you got? 27? No. Cylindrical wire, I said, what is the volume of cylindrical wire? Pi r square into L. Pi r square into H or pi r square into L, you have to take. How much? 1.2 into 10 power? No. No. 1.8. You got that? You got that? Where you got? Show me that. How you got that? You reached that? Then where you got that formula? Where you got it? ಎಲ್ಲಿಂದ ಬಂತ ಅಂತ ಹೇಳಿ ಎಲ್ಲಿಂದ ಬಂತ ಫಾರ್ಮುಲಾ? ಯಾವಾಗ ನೋಡಿದ್ಯಾ? ಇವಾಗ ನೋಡಿದ್ಯಾ? ಮತ್ತೆ ನೀವೆಲ್ಲ ಪ್ರಿಪ್ರೇಷನ್ ಮುಂದೆ ಆಗ್ತಾಯಿದ್ರು ಅಂದರೆ ಯಾಕೆ ಕ್ಲಾಸ್ಗೆ? Formulas whichever I did not teach also, he got that formula and then he have written that. Methodology ಗೊತ್ತಾಗಬೇಕು ಸರ್, ಫಾರ್ಮುಲಾಸ್ ನೆನಪಿರಲ್ಲ. Shall I? What is the delta d by d, by the way, you got? How much? 6 into 10 power? Minus 4. That's correct. Then after that only you are not getting. Errors you are not able to apply. See that? Sigma is equals to, what is the formula for us? Delta d by d divided by delta L by L. Sigma is how much they have given? What is the sigma value? 0.2 na? That is equals to delta d by d is equals to sigma into delta L by L. What is the percentage change in length they said? How much? Longitudinal strain. That is what? No, delta L by L. How much that is? 3 into 10 power minus 3. They have not given percentages, they have given directly 3 into 10 power minus 3. Then delta d by d is equals to, can I write it as delta r by r? R by 2 divided by r by 2 you will get. Clear? I am sorry, 2r you will get, 2 gets cancelled. So delta r by r also same only, that is how much? 0.6 into 10 power minus 3. This is a delta r by r we got. And then even delta d by d also same only. You are understanding what I am doing here? D nothing but how many times of radius? 2 times of radius. 2r and then 2r, 2 gets cancelled, everything is same only again. Delta r by r is equals to 0.6 into 10 power minus 3. Now the thing is they are asking the volume. First of all, what is the volume formula of the cylindrical wire? Nothing but pi r square into L. Cylinder formula is a volume of the cylinder is pi r square into H. In case of wire of length L, that is pi r square into L. Now you have to find out the percentage change in the volume. Percentage change in the volume, nothing but what you have to do? Delta V by V you have to do. First of all, delta V, what is that? Delta V by V is equals to, what you can write here? 2 into delta R by R plus delta L by L. That's it, you will get the answer. What you have done here? Multiplication only you have done, delta 2 into delta r by r plus delta L by L. Then what about the pi? That is a constant, there is no change in that. There is a change in the radius, so only 2 into delta r by r. There is a change in length, so only delta L by L. There is no change in the constant, so only I did not take that. So 2 into delta r by r, nothing but how much you will get? 1.2 into 10 power minus 3 plus delta L by L is how much? 3 into 10 power minus 3. Then what is the answer you will get here? 4.2 into 10 power minus 3. This is the delta V by V. Clear? In percentages you have to take nothing but again you have to do it as divided by 100. Did we take minus there? What happening? Length is increasing and then diameter is decreasing, right? Our answer is wrong. Minus ಮಾಡಬೇಕಿಲ್ಲಿ. Not really. Sigma is equals to, what is the formula for us? Minus delta d by d divided by delta L by L, right? So what will get here? Minus delta r by r will get. Whenever you substitute here, what will get here? Minus. Nothing but how much will get here? 1.8. 1.8 into 10 power minus 3. That is the correct answer. Error. Error in error again. See that, look at the problem. They have given it as Poisson's ratio of one wire they have given. What is the Poisson's ratio they have given? 0.2, and the longitudinal strain they have given as how much? 3 into 10 power minus 3. What you have to find out? Percentage change in volume you have to find out. For that purpose, first of all you have to take the sigma formula. Sigma is equals to, what is the formula? Minus delta d by d divided by delta L by L. What this minus indicates here? Diameter will decreases whenever the length is increasing. So that minus delta d by d is equals to, what will get here? Nothing but here 3 into 10 power minus 3 into 0.2. Why? Because sigma is 0.2 and then delta L by L is how much? 3 into 10 power minus 3. From that, minus delta r by r is equals to how much you got? 0.6 into 10 power minus 3. If you got the diameter ratio or the radius ratio, both are same only. Then you have to find out the volume. For finding the volume, volume is equals to, what is the formula for us? Pi r square into L. Change in volume, percentage change in volume, relative error. So for the powers, how to do the relative errors? Power will come front and then you have to apply the delta. And then whenever multiplication of quantities are there, for example, already we have discussed that a power a, b power b and then c power d, like this it is there. Then what you have to do? Delta x by x is equals to, what I can write here? A into delta a by a, then plus b into delta b by b, then d into delta c by c, plus only. You should not apply the minus, always error should be added, so only you have to take it as plus. So here v is equals to pi r square into L. From that, delta v by v is equals to, power will come in front, so that 2 into delta r by r plus delta L by L. But delta r by r is how much we are getting? Minus 0.6 into 10 power minus 3. So whenever you apply that, this is minus 1.2 into 10 power minus 3 plus the length is how much? Length is changing as how much? 3 into 10 power minus 3. From that, how much you will get the answer as? 1.8 into 10 power minus 3. And now you have to find a percentage, nothing but what you have to do? Into 100, then what will you get here? 1.8 into 10 power minus 1. That is a percentage change in the volume, delta V by V into 100. Whatever delta V by V we got, for that you have to do just into 100 whenever you will get the percentage. Otherwise I can write it as clearly, what I can write? 0.18%. This is a change in volume. Decreasing or increasing? Increasing, there is no minus there. Obviously it is increasing. Next problem. Determine the Poisson's ratio of the material of a wire Ramesh, fan on. Determine the Poisson's ratio of the material of a wire whose volume remains constant under an external normal stress. See, what is the Poisson's ratio of any material? Maximum value will be how much you'll get? 0.5, right? That 0.5 only you have to prove now. They are saying that under normal stress only, right? Under normal stress you have to find out the Poisson's ratio of the material, but here one condition is there, whose volume is constant. Volume of the material wire is constant means, what is the volume formula for us? V is equals to, what is the volume of a wire? V is equals pi r square into L. So pi r square into L. But now we are having the Poisson's ratio in terms of what? Delta D by D divided by delta L by L. We are having in terms of what? Diameter. Instead of radius you have to take it as a diameter. Then volume is equals to what I can write here? Pi into, in the place of r what we can write? D by 2. Diameter divided by 2 only. R is equals to what I can write? D by 2 whole square into L. Nothing but I can write it as pi by 4 into D square into L. Correct volume? You understand that clearly? Now you have to find out what? Volume should be constant. Volume should be constant. I want to get the deltas. So that what you have to do here? Volume is constant means differentiation becomes how much? 0. Change becomes how much? 0, right? Obviously. So that you have to do the partial differentiation here. Whichever you are doing the differentiation, that component only you have to take. So here, which are variables here? Volume is variable, but they said that it is a constant. And then diameter is a variable, length also a variable only. But pi by 4 is a constant value. So here, you have to do the differentiation. Whenever you do the differentiation, here dV we will get, dV is equals to what I can write here? 2 into dd. 2 into dd plus what will get here? dl. Don't confuse much. Just you have to do the differentiation. Whichever are variables, for that only you have to do the differentiation. Here volume is variable, diameter is a variable, L is a variable. What about the pi by 4? Constant. Is there any differentiation for that? Differentiation of constant becomes how much? 0. I am applying U into V method formula only. In that, you have to take as what? D square into, D square is a, what is that? D square is a variable, nothing but 2 into dd. Then which is constant here? L is constant. Differentiation of U into V formula. U into dV plus V into du. D of U into V is equals to what is the formula? U into dV plus V into du. That is what I am doing here. So that here V into du I have done. Then what will come here? D square into dl. Correct? So V into du. V is L and then U is D square. So V is L is constant. D square nothing but what will get here? 2 into dd. 2d dd, right? Yes. 2d and then dd. What is dd means? Difference in d value. D square nothing but what is differentiation you will get? 2d. So that 2d into dd plus U is constant, you have to differentiate the V. So that only what will get here? D square into dl. They said that V is constant. V is constant, nothing but that will become how much? 0. Then what is remaining for us here? D square into dl is equals to what I can write? Minus L into 2d dd. Then what will get cancelled here? dd gets cancelled. Then what you can get here? D by L is equals to what I can write? Minus dd by dl. Correct? Then 2 is also remaining, right? Where is 2? Here it is 2. 2 is there here. Then what is our Poisson's ratio formula? dd by d divided by dl by l. So that Poisson's ratio is dd by d minus dd by d divided by dl by L. What is dd by d? Nothing but dd by d is equals to what I can write? From this dd by d is equals to what? dl by L into how much you will get? 1 by 2 you will get, right? So that what I can write here? Minus 1 by 2 into dl by L. Correct? So in the place of dd by d, I am writing it as minus of minus 1 by 2 into dl by L. That divided by dl by L. What happens here? dl by L gets cancelled, minus minus gets cancelled. Sigma is equal to how much you are getting? 1 by 2. So that what is the value? 0.5. That is our true value, right? 0.5. Listen again. They have given one material. For that they said to find out the Poisson's ratio. They have not given the Poisson's ratio, but they have given one condition that its volume is constant. Volume is constant, and then they are asking the Poisson's ratio, nothing but first of all you have to take the Poisson's ratio formula. Sigma is equal to what is the formula for us? Delta d by d divided by delta L by L. Nothing but here they said volume is constant, nothing but something you have to do with volume only. So write the volume formula. Volume is equal to what is the formula? Pi r square into L. And also in our Poisson's ratio, what we are having? Diameter and then length. Here what we are having? Radius and then length. Instead of radius, what I can take? D by 2 I can take. So that d by 2 whole square I have taken, and then that pi by 4 I have taken out, and then d square into L is there. So clearly what I can write here? Nothing but V is directly proportional to d square into L. Clear? Now they said that volume is constant. Volume is constant, nothing but delta V becomes how much? Any constant value, for that change becomes how much? 0 only. So for that, first of all I have to apply the differentiation here. For applying the differentiation, V variable, D variable, and then L variable. This is in the form of what? U into V. So that I am doing the differentiation for the V, so that dV is equals to differentiation of U into V formula. What is that? Differentiation of U into V here I am doing is what means D into V is equals to D into D square into L. This is what I am doing. I am just doing differentiation both the sides. With respect to what? With respect to nothing. With respect to the same value only again. You don't think it as a with respect to the time or with respect to the displacement and all. Just change with respect to that value itself. So that only dV, just differentiation, dV is equals to D into D square into L. So dV is equals to, this is in the form of what? Differentiation of U into V formula. Differentiation of U into V formula nothing but U into dV plus V into du you will get. So that U into dV, V into du. Take it as U, this one as V. Then what you will get? First of all U into dV. U is which one? D square. D square into V is which one? L. So that D square into dl plus next one is what? V into du. V is which one? L. U is which one? D square. So that L into d square. Differentiation of d square is what? 2d. We are differentiating with respect to what? Distance on diameter only, so that dd I have written. Then differentiation of volume becomes how much? 0. Why? Because volume I said what? Constant. Differentiation of constant becomes how much? 0. So that it is becoming as 0. Then d square into dl is equals to minus L into 2d dd. I can cancel this dd here. Then we got the ratio of d by L. The ratio of d by L, otherwise directly this ratio I can take. dd by d is equals to 1 by 2 into dl by L. I am sending everything that side and then this side. Then you have to take the sigma formula. Sigma is equals to what is the formula for us? Minus delta d by d divided by delta L by L. So delta d by d, in the place of delta d by d what I can write? Minus 1 by 2 into delta L by L. That is what I have written here. But here already minus is there for us in the formula. So minus of minus becomes how much? Plus delta L by L gets cancelled. What is remaining here? Just 1 by 2 is remaining. 1 by 2 value is how much? 0.5. If you don't do this problem again, you will not remember this one. You cannot understand even. You have to practice that on the paper. Copy that. That is a theoretical value. They have not given anything here. They have not given any value, but we got the final value here. That is a theoretical value, 0.5. That lies between where? Theoretical value lies between -1 to 0.5. Next one is angle of twist. This problem they cannot ask in other way. What they said, everything is theory, they said that volume is constant, that's it. So they cannot ask in any other way, there is no other substitutions, nothing, there is no other solution only for this. So directly sigma already you know the value, 0.5 you know, but I am proving that as sigma is equals to obviously 0.5 only theoretically. Clear? This is just proof of that value, that's it. Then don't worry about that this kind of problems will come and all. This kind of problems will not come. Why? Because already you know the value. Sigma value already I said you. So you remember that. Is there any numerical values they have given in this? Nothing is there. Directly they are asking about the sigma. We have proved that as how much? 0.5. This is just proof only. Then next one is angle of twist. Angle of twist. And for this concept, presence of mind should be there. You have to understand that properly. Give me that notes. Twist notes. Oh, notes then. Yes. See that? First of all, I have taken a cylindrical wire. Upper edge is fixed. Twist nothing but what you are doing, you are twisting this. So this concept only will come again in the oscillation chapter also. Okay, there also torsional pendulum will get. One concept will be there, torsional pendulum. So same concept only, listen properly. Now what I am doing nothing but I am just fixing the upper end, and this is, you just assume this as a cylindrical wire only. Now on the cylindrical wire I am applying some force. Somehow you can apply the force, that might be tangentially or that might be normally, anyhow. But what you have to do nothing but you have to twist the wire. For twisting the wire, before twisting the wire, this is just a wire only. For that wire, length is how much here? L is the length we will get, and also the radius is how much nothing but whenever you twist the radius is R obviously. So that here radius is R, here length is L. Now what I am doing nothing but I am just holding it like this and then I am applying a twisting force. At that time you just observe the center line. You just observe the center line here. How that is displacing you have to observe mainly. You are able to see that? Yes. Now whenever I just twist it, at that time this line will displaced. How it will displace you have to find final edge and then initial edge you have to find out. Final point and then initial point you just observe. Now what I am doing nothing but I am twisting. Then what happening? They are at the same position, otherwise they are displacing. Initially it was there here. Now what happening? It is moving here. Correct? Displacing or not? So that here what happening nothing but shearing is happening. Shear strain is produced there. How much nothing but phi is the angle. But in the below bottom also what happening? It is also displacing. That is also twisting at some angle. That is the twisting angle. This one is twisting angle and then upper one is what? Shear angle. See that this line will move little bit. You observe that line was there before like this. Now whenever I twist, at that time it is little bit it is displacing. So very small strain only will be produced. In case of shear strain, what I said, always it will be very small. So very small shear strain is producing at my hand, and at the right hand what is happening? Nothing but angle of twist is producing. Clear? Any circular thing is there means I can show you. Any circular rubber like that it is there means I can show you easily. But here you are able to assume at least little bit. This line is displacing like this, correct? So that angle is which angle? Shear angle. This point is displacing from here to here by just gaining some angle like this. So see my fingers, whenever I hold like this, then I am just twisting. Whenever I twist, then what happening? Nothing but this end is fixed only. This I am twisting nothing but this finger also, this forefinger also displacing by some angle. So that angle is angle of twist, and then this angle is how much? That is angle of shear. So I will just draw you in the diagram, then you can understand. So here, before the line was, middle line was there like this. Middle line was there like this straightly. Now whenever I twist it, nothing but I have to apply the force in this direction, inwards, and then here I would have to apply in outward direction. Then at that time what happening? Nothing but this line is becoming like this. This line is just displacing here, and then this one is going here like this. Correct? Back side, I am saying about the back side. Now here from this center, if you observe, from this center, this one is coming here and then this one is going here. 3-dimensional diagram you have to observe here. So here the lower surface is displacing whatever I said in between, angle between my fingers only. The lower surface is displacing from here to here like this back side, and also the top surface also displacing like this. For example, if you observe my hand clearly, whenever I twist my hand like this, see that this one you see this one is the first middle line I have got, and after that what I am doing? Nothing but I am applying the force like this. So whenever you see the finger is displacing or not? Finger is displacing. So that it was there before, it was there like this. Now what happening? Nothing but it is becoming like this. So here angle is which angle produced? Shear angle. And also the same finger only, it was there before here, and then this is going here. It is also turning some angle. How much angle? Nothing but angle of twist theta. Clear? And now you understand at least. So get some idea, that's it. So this is theta here, and this is the angle of shear, that is phi. Now let me take this point is moving from P to P dash here. How much angle I covered? How much arc I covered? Nothing but P to P dash is the arc I covered. So that P to P dash, whenever I take the bigger arc, this sector I have taken. So this is the length of the cylinder obviously. Whenever I take this sector and the radius of the cylinder is r here, whenever I take this sector, the bigger sector if you draw, that is there like this, P and then P dash, here angle of shear is how much? Phi. So P and then P dash is equals to what I can write here? The big sector length is how much here? Arc length is how much? Radius is how much? L, and then arc length is how much? P to P dash. So that P to P dash is equals to, arc length is equals to what I can write? Theta is equals to what is the formula? Arc length by radius, right? Theta is equals to arc length by radius. Arc length is what? P to P dash here. Radius is how much here? L. So that angle is how much? Phi. So that what I can write here? Phi into L. Then second time, if you see the smaller sector, like this we got the sector, and then here angle is how much? Theta, and then P to P dash here. For that here radius is how much? Smaller radius is R. Then again P to P dash is equals to, arc length is equals to what I can write? R into theta. Whenever you see both the lengths are same only here, what I can write then? Phi L is equals to R into theta, then theta is equals to phi L by R. This is the angle of twist. Theta is the angle of twist, and then phi is the angle of shear angle, that is. Clear, right? If possible, tomorrow I will find something circular thing I can bend, and then I can show you easily by drawing the lines and all. Clear? This line is nothing but the center line of the wire, whatever we have taken. So that is how it is twisting, and then how it is displacing we are seeing here. Clear? Copy that. Any wire is there means you can get even. Circular wire, circular sponge also, anything. It